we talked about setting up sample spaces using tree diagrams. But now when I look at, and I follow this path and I go, okay, remember I said if we follow this path, this goes to G, this is A. So this whole path is about G and A. This path, G and not A, or G and A complement. All right, here I go here and here. So this is R and A. R and A complement. B and A. B and A complement. All right, so this is my complete set. This is my, if I was going to list my sample space, this would be it. The probability of each of those I get by multiplying. It's an and. G and A is the probability of G times the probability of A given G, which is there. So I'm just going to multiply these probabilities. So this is going to be, so if I put the probability of these two, this is going to be 0.25 times 0.85. The probability of G and A complement, 0.25, 0.15. Right. This one's going to be 0.33 times 0.56. This will be 0.33 times 0.44. 0.42 times 0.71. This is 0.42 times 0.29. And if I multiply all those out, this ends up being 0.2125, 0.0375, 0.1848, 0.1452, 0.2982, 0.1218. And if I sum these all up, this is my sample space. So if I sum all these up, they better add up to what? 1. They have to. This is, every possibility is set right there. So this, when I include all these different probabilities, I have the probability model for my entire sample space here. So when I want to ask, what's the probability of A? All right, let me make this small. I want to look at everything, all of my outcomes that have A in it. There's G and A, R and A, B and A, all right? So these 3 probabilities are the probabilities that involve A happening, all right? So this is going to be 0.2125 plus 0.1848 plus 0.2982, which we already calculated above, but this is 0.6955. The probability that he doesn't order Alfredo, obviously I can get, using the complement rule, it's 1 minus the probability of A. But I could have also gotten that by adding everything that's about A complement. There's this one, and this one. I could have added these 3. Obviously, that's going to be 1 minus that. Okay, so now we're looking at conditional probabilities and the general multiplication rule. Have a good night or day or whatever time you're watching this. I'll see you in class.